Okay, so can someone give me a quick node if it is visible to all of you? Okay, so please be active because there are a lot of questions we are going to solve. I need your help also for your our calculation part also. Okay, so let's start with the first thing first. What we have is the incidence. So this is what a number of new cases that is occurring in a defined population during a specific time period. So let me change my pen color first. So you have to remember two terms. The first thing first is the new cases and a specified time period in which that new cases are occurring. So the formula what we use to calculate the incidence is very simple. It's like a number of new cases of a specific disease during a given period upon population at risk at that time into 1000. So let's solve with an example for it. Suppose you are following around 30,000 smokers in your study. Suppose you are following around how much? 30,000 smokers for 1 year. Suppose this is from Jan 1st to 31st December 2023. Out of this 30,000, you have noticed 500 develop COPD. So can someone find the incidence for it? Anyone? Any guesses? You just have to put few numbers into the formula. You will get the prevalence. So you will get the incidence. Anyone? So question is like you are following around 30,000 smokers for 1 year and out of 30,000, 500 develop COPD. So you have to find the incidence at that point of time. Any guesses? So how to solve it? We have to put these two variables into our formula. So it will go like 500 upon 30,000 into 1000. You will get around 16.7 per thousand. Per thousand. This is your answer. This is the way to find your answer. So there is one more practice question for you all. I need your active participation. Suppose we have 10,000 alcoholic and you are following them for 1 year. You have how much? You have 10,000 alcoholic. Let me write for your reference. You have 10,000 alcoholic and you are following them for a year. Out of 10,000, 250 develop chronic liver disease. Find the incidence. Question is very simple. Out of 10,000 alcoholic, 250 develop alcoholic chronic liver disease. Now you have to find the incidence of it. Yes, you are going very well. Ravindra, Soumya, Shruti, yes, you are going very well. Others? Others, please be active so you can learn properly how stats work. So answer is yes, 25. And how we find it? Just simple thing, 250 upon 10,000 into 1,000, you will get around how much? 25 per 1,000. This is your answer for it. I hope this part is clear to all of you. Any doubts for this part? Anyone? Okay. The next part, what we have is the prevalence. So prevalence is like what? It is like a current cases, including old and new one. So in the first part, what we have learned, we have to take all the new cases that is happening in the given time period. So what is prevalence now? This is the number of current cases, including old one and the new one in a given point of time or in a given time period. That is known as prevalence. So formula is very simple to go. It is like total number of cases, old plus new at a given point of time upon estimated population at the same point of time into 100. So little bit we will go advanced for the prevalence part. So prevalence part is of three different types. We have first thing first is the point prevalence. Second thing what we have is the period prevalence. And third part what we have is the attack rate. The first thing what we have is the point prevalence. Second part what we have is the period prevalence. And the third part, what we have is the attack rate. These are the sub-classification of prevalence part. So what is point prevalence? It is the outcome on a specific point of time. So what will be the period then? This is your outcome in a given time period. So let me take one example for you all. Suppose you are following around 150 individuals in your society, and out of 150 people, you notice 25 develop diabetic mellitus in your society for a given time period. Suppose for 1 year you are following your society members. So out of 150, 25 develop diabetic mellitus. So this is what? This is your point prevalence, because at certain point of time you will take some follow-up. Suppose you are taking a follow-up on third month. So on third month, you notice out of 150, 25 develop diabetic mellitus. So your formula will go around 25 upon 150. So this will be your point prevalence. So if you are taking any prevalence on a given point of time, it might be 2 months, 3 month follow-up, 6 month follow-up, as per you like, that will be your point prevalence. Now suppose out of 1 year, out of 150, more 15 people develop diabetic mellitus in my time period. So that will be known as period prevalence. So how to write this part? 25 plus 15 upon 150. This will be your period prevalence. Now we have one more thing, that is the attack rate. So what is the attack rate? This is nothing but just like the occurrence of a new cases in a population during a decided time period. So how to find the attack rate? It's very simple. So just remember, in the initial follow-up, out of 150, 25 develop diabetic mellitus. So you have to remove this number of patients from 150. You will get how much? 125. And if you can recall, in our remaining few months of the follow-up, 15 people develop diabetic mellitus. So how to make it? 15 upon 125. This will give you the attack rate. It will come around 0.12, or we can write it as 12%. Any doubts till now? For the prevalence, for the point prevalence, period prevalence, and the attack rate. Any doubts? Anyone? Okay. Suppose you are doing 1 year study in your tertiary care centers or in your office or in your teaching place, out of which you are following around 150 population for 1 year. Yes, we are doing. So we have three type of prevalence, that is point prevalence, period prevalence, and the attack rate. So what is point prevalence? Suppose I am following 150 normal individuals for an entire year, and I put in my study protocol, I will follow my patients on given point of time. Suppose I am following on the 6 month. It's my first point of intervention or follow-up. I noticed on 6 month, on a specific 6 month, out of 150, 25 patients develop diabetic mellitus. That will be my point prevalence. Suppose after 6 months, 15 patients more develop diabetic mellitus. That will be your period prevalence. That will be how much? 25 plus 15 upon 150. That will give you your period prevalence. Now, how to find the attack rate? So, out of 150, in initial time period, let me change my color. So, out of 150, in initial follow-up, that was 6 months, 25 developed the diabetic mellitus. So, remove out of it. So, how much we will get? 125. Now, after 6 months of my follow-up, I noticed 15 more individuals develop diabetic mellitus. So what to do now? We will do 15 upon 125. It will give me around 0.12, or change to percentage, it is like 12%. This is your attack rate. So I hope this part is clear now. Any doubts? Any doubts? Fatima, Riaz, others, Shruti, Prachi, any doubts? Fatima, significance of doing attack rate. In normal studies, we are not doing the attack rate, but this is just a part of prevalence. That part you should know if something come in your exam part. But for the study part, we will go only for the point prevalence and for the period prevalence. And to be very specific, on the practical level, we will only go for the period prevalence. Prachi, okay. So things are very simple. Just try to follow me. Suppose, okay, let me have a plain page for you all. Okay. Suppose you are doing one study in your center. You are following around 200 individuals. They are completely all fine, all healthy. Okay. In your protocol, you have mentioned, I will call my patient back for a follow-up on 6 months to check whether they have developed or not a diabetic mellitus. Suppose on 6 month patient came to you and out of 200, you notice 50 of them developed the diabetic mellitus. This will be your point prevalence. Why point prevalence? Because this is the time period what you have decided for the follow-up. That is your point prevalence. Now suppose after 6 months, 15 more people develop diabetic mellitus. So what to do now? 50 plus 15 upon 200. This will give you the period prevalence. So what is your period? You have decided that I will do my study for 1 year. And in 1 year, 50 plus 15 develop diabetic mellitus out of 200. So this will give you your period prevalence. Now, sometimes your questionnaire may come up with the attack prevalence also. What is the attack rate? What is the attack prevalence? So what to tell now? So out of 200, we have to remove this 50 people who develop diabetic mellitus on my follow-up. So what I will get? I will get around 150 in my lower value. Now I noticed after my follow-up, 15 people also develop diabetic mellitus. So what to do now? 15 upon 150. You calculate it and change to percentage. This will be your attack rate. So for your study purpose, for your research purpose, always go with the period prevalence. If you want to write, you can write point prevalence also. But for the study purpose, there is no use of attack prevalence or attack rate. But this part you should know if something come up in your main exam. I hope this part is clear. Prachi, Shruti, Fatima, anyone? Any more doubts? Any more doubts? Okay, so I think we can go to the relative risk ratio. So this is like what? A ratio of incidence of the disease or a death. It depends on your outcome. Like if you want a disease to be happening or that to be happening, you can fix on your protocol. So this is what? A ratio of incidence of disease or death among the exposed to the non-exposed. So once you put all the numbers into the formula, you will get few numbers as a result. Suppose I put few things in the formula and I got my number around 4. This is my relative risk ratio. So if RR is equal to 1, then there is no association between the exposure and the disease. If RR is more than 1, this indicates the positive association. That means it is harmful. Suppose I found something out of it and I found alcohol and chronic liver disease. It is showing relative risk of 4.8. It is showing that patients who are alcoholic have more relative risk of developing chronic liver disease. Now suppose I am getting vitamin E and the fatty liver, and I am getting the RR ratio of suppose 0.8. It is showing the positive factor now. So this will show. So in short, if RR value is equal to 1, then there is no association. If RR value is more than 1, that means there's a positive association between the factor and the disease occurrence. If RR is less than 1, it is showing the negative association. It might be a positive factor. Now, let me give you one simple example with the help of smoking and RR. So please try to follow me what we are doing now. Suppose we have a population of 500 smokers, normal individuals. So out of 500, 80 are the smokers. 80 people do daily basis smoking. Now out of 500, 125 individuals have MI, and among them, 45 are the smokers. In short, we are taking around 500 individuals Out of 500, 80 people smoke. Out of 500, we have people with MI around 125, and among 125, 45 people smoke. So we have to find the relative risk, whether smoking is a factor for causing MI or not. So first thing first, what we will do, we have to create 2 by 2 table. The first step will be 2 by 2 table. So let me change my pen color for your reference. So how to make this table? You have to make like this: myocardial infarction. So this will be first thing, yes or no. MI is there or not? Simple thing. On the left side, we have to put smoking. Smoking, yes and no. This is the table that you have to make in your notebook, total and total. So it will go like this. So if you can recall, the first part is MI, yes, and smoking, yes. So out of 125, how many were smoker? 45. So MI is also there and smoking is also there. So what value will come over here? Any guesses? Any guesses? One patient is there, he or she is having MI and smoking factor also. Yes, you all are going perfectly fine. 45. Now MI is there, but there is no smoking. So what we will write? Any guesses? MI is there, but no smoking. So what to do? Yes, perfectly fine. All are going perfectly fine. 80. The same way we have to follow. MI is not there, but smoking is there. MI is not there, but also smoking is not there. So if you found this value, it will go around 35 and 340. Now we have to calculate, we have to total it. Suppose this is A, this is B, this is C, and this is D. So here what it will come? A plus B, here C plus D, and here A plus C, and here B plus D. And here what it will come? Any guesses? Sum of this and this and sum of this and this will be same. So A plus B or C plus D, or we can take sum of A plus C plus B plus D. This is how you will make a table. So let me rough it for your reference. Okay, so we will make it clear. So please do help me with the calculation part. 45 plus 80, how much it will be? 125. 35, 340, how much it will be? 375. Now 45 plus 35, how much? Any guesses? Like 80 it will be, and B plus D, how much? 420. Now if you add this thing, or if you add this part, this two and this two, it will give the constant or same number. That will be how much? 500. This number is matching with our initial population. So this is how you will create a 2 by 2 table for your relative risk. I hope this part is clear. You just have to follow diagram. You just have to follow a question. Just follow MI is there, smoking is there. Write the number. MI is there, but smoking is not there. Calculate it. The same way we have to follow for the MI is not there and smoking is there, and MI is not there and smoking is also not there. This is how you will make your 2 by 2 table. So once you create this 2 by 2 table, we can proceed with the calculation part. So let me have a clear slide for you all. So we have to find the incidence of MI in smokers. So MI in smokers. So we will take this part and total part. So what it will give us? 45 upon 80. So if you calculate this part, you will get around 0.563. Now we have to find the incidence of MI among non-smokers. So what we will do? MI is there and no smoking part they want to take. So what we will take? We will take around 80 upon 420. If you calculate it, you will find around 0.191. Now, please repeat the question. Okay, so question was like, out of 500, 80 were the smokers, and out of 500, 125 found to be have diagnosed with MI, And out of 125 patients with MI, 45 patients smoke on daily basis. This was your question. Further, you will create a 2 by 2 table. Write MI on the top, yes, no. Smoking, yes, no. This were clearly mentioned in the question itself only. The question was very simple. Total of individual, how many were we having? 500. Out of 500, 80 were the active smokers. Now, out of 500, 125 were having MI, and out of 125, 45 were the smokers. In that way, you have to create this 2 by 2 table. So once you create this table, now we will find the incidence of MI in smokers and MI in non-smokers. So what we will do for the smoker part, MI is there. So 45 upon 80, you will get around 0.563. And incidence of MI in non-smokers. So MI is there, but smoking is not there. So 80 upon 420, you will get how much? 0.191. Now we have to put this value. Okay, so let me mark it A and let me mark this part as B. So let me have a clear slide. Okay, so what is the formula? If you all can recall, for RR, it goes around incidence of MI in smoker, incidence of MI in smokers upon incidence of MI in non-smokers. So we have to put A upon B. You will get how much? 0.563 upon 0.191. It will come around 2.95. So now we can tell this RR ratio is how much? 2.95. It is more than 1. So it indicates what? It indicates the positive association between the smoking and the MI. I hope this part is clear. After the class, I will give one question in the group so you all can practice 2 by 2 table and the RR ratio also. I hope this part is clear to everyone. Others? Sandeep, Prachi? Okay, so I think we can move on now to our next question, topic that is attributable risk, that is AR in short. So this is what a difference in the incidence rate of disease or death between the exposed group or non-exposed group to incidence among the exposed group. So to make it simple, just try to follow the formula, that is AR is equal to incidence of disease among exposed of disease among the non-exposed upon the incidence of disease among exposed. This is nothing, just a minus sign in between. So we can follow the same formula, the same thing what we did this side. Okay, so try to get this A and B only. We will take this A part and the B part for this formula also. So if you can just recall the formula, it is like what? AR will be like what? Let me change my pen color first. So AR is like what? Incidence of MI in smokers minus in non-smokers upon smokers. So let me write for your reference, incidence of MI in smokers minus incidence of MI in non-smokers upon incidence of MI in smokers. So if you put this values, what we just obtained in the last slide, it will go around how much? Let me have a clear slide. It will go how much? Let me change my pen color also for you all. It is 0.563 minus 0.191 upon 0.563. So you will get around 66.1%. This is how you find the attributable risk. The formula is very simple. Incidence of disease in a population that is exposed minus non-exposed upon exposed population. So just try to follow formula what we were doing for the MI and smokers. We found the prevalence of smokers and MI about 0.563. In non-exposed group, it was how much? 0.191. So put the formula of attributable risk. It was what? Exposed group minus non-exposed group upon the exposed group. So if you put this formula's number in the formula, you will get some percentage out of it. This is your attributable risk. I hope this part is clear. Any doubts? Anyone? Shruti, Prachi, Unisha, Fatima, anyone? Okay. Uh, okay. So one more time, please. Okay. So what is attributable risk? The formula is very simple. Just remember two terms. That is exposed group minus non-exposed group upon the exposed group. This is your simple formula for the attributable risk. Again, I'm repeating, exposed minus non-exposed upon exposed, you will get the formula for attributable risk. Now, in the previous 2 by 2 table, we found the prevalence of MI in smokers who were exposed and MI in non-smokers who were non-exposed. So, how much we got for prevalence for MI in smokers? It was 0.563, and MI in non-smokers, that was non-exposed group, was how much? 0.191. Now recall the formula. That was very simple. Exposed minus non-exposed upon exposed. So it will go around 0.563 minus 0.191 upon exposed group again, that is 0.563. If you want, you can put 100 also, you will get the percentage value out of it. So once you solve it, you will get around 66.1%. This is your attributable risk factor. I hope this part is clear now. Any doubts? Anyone? Fatima? Others? Others? Okay. This part is done. The next part, what we have is the odds ratio. So odd ratio is like what? Strength of association between risk factor and the outcome. Suppose I'm telling people with a higher disease severity score have more risk of death. Suppose I'm doing some study, some retrospective prevalence study, and I found odd ratio of 3.0 for higher MELD score, higher MELD score and death rate in chronic liver disease. So what I will tell now, patients with higher MELD score have 3 times higher rate of mortality. This is what odd ratio tells us. It will tell us the relation or association between the risk factor and the outcome. It can be a disease, it can be a mortality factor also. This is what odd ratio goes like. The next part, what we have is the odd ratio formula part. So formula goes around P upon 1 minus P. Here P is what? Probability. Probability. Now, let me simplify it for you all. P is like what? Event will happen. Event will happen. And 1 minus P is like what? Event will not happen. Event will not happen. This is your codes for the formula. Just simple P upon 1 minus P. This is your formula. And let me give you one question. Suppose today probability of raining is 0.2, or let me make it simple, it is 20%. Now can someone find the odds favoring the rain today? Can someone solve it for me? The question is very simple. Anyone? Prachi, Fatima, Shruti, Ravindra, Unisha, Sandeep, anyone? Okay, so question is, probability of having rain today is 0.2 or 20% for your reference. So what are the odds favoring rain today? I need the number. I need the answer out of it. Yes, perfectly fine. You all are going perfectly fine. Ravindra correct. Suruchi correct. Ravindra, I am correct. Okay. So let me solve it for you all who didn't get the question or answer. So my question was, probability is how much? 0.2 for raining today. I want the odds of favoring the situation. So what is my formula? P upon 1 minus P. So this is what event will happen, event will not happen. So our event odd ratio was how much? 0.2. So put in the formula 0.2 upon 1 minus 0.2. So what you will get? 0.2 upon 0.8. So if you solve it, you will get around something around 25%. This is your answer. Any doubts for this part? Anyone? Yes, you are correct. Others? Any doubts? Anyone? No, it can be number also, but if you want, you can put 100 to make it a percent. There is no problem if you are writing 25% or 0.25%. Answer is same. Any more doubts? Others? Okay. So I think we should move on to our test for significance. Now we have two type of test. The first is parametric and non-parametric test. So let me go more deep for the parametric test part. So you have to apply parametric test only if you have data that is normally distributed. Always check whether data is normally in a pattern or not. If it is not, then go for the non-parametric test. In the coming slides or in the coming classes, we will learn about the Shipro-Will test. We apply Shipro-Will test to identify whether data is normally or not. So if it is significant, that indicate your data is normally distributed. If it is, then you have to apply the parametric test like t-test and ANOVA. In ANOVA, if you want, you can go further to the post hoc analysis. The next part, what we have is the non-parametric test. This test you have to apply when your data is not equally distributed. And if it is not possible to change into the normal distribution, then you have to apply non-parametric test. Example for such tests are chi-square, Wilcoxon test, Mann-Whitney test, and Kusal-Wilks edge test. I hope this part is clear. You have to remember only two terms. Apply Shipro-Will test. Please show the previous slide. Okay. So you have to remember only one thing. Apply Shipro-Wilk test. It will show some significance or not significant. If it is significant, that means your data is normally distributed. If it is, then you have to apply parametric test like t-test, ANOVA, post-hoc analysis you can apply. If it is not significant, that means your data is not equally distributed. Then we have to apply for non-parametric test. It includes chi-square, Wilcoxon test, Mann-Whitney test. I hope this part is clear. Any doubts for this part? Others? Ruth, Sandeep, Prachi, Fatima, Ravindra, Shruti, Unisha. Any doubts? Yes, Fatima, we will go to SPSS further. So this is just a glimpse of what you are going to practice in software. So don't worry. So this is just your base. Okay. So let me have this flow chart for you all. So if you are doing some research, you might notice in your data, you have two type of data. In one data, you will write male, female, or you have like school pass, graduate pass, school pass, graduate pass. That will be your ranked data. In other variables, you will find your lab values are there, like 18, 19, 12, 24, 98 in all this part. That will be your continuous data. So let me cover up the first part is ranked data. So for the ranked data, you have to always apply non-parametric test and check whether your group is paired or unpaired. If it is paired, then how much group are there? If it is 2, directly go with the Wilcoxon test. If it is more than 2, apply Friedman test. The same thing we have to follow for the continuous variable. First, you have to apply Shiprover test. If it is significant, that means your data is equally distributed. If it is yes, then apply design parameters, whether this is unpaired or paired. If it is paired, then again check how many groups you have. If it is 2, then apply pair t-test. If it is more than 2, apply repeated measures of ANOVA test. If it is unpaired, then again check for the number of groups you are having, 2 or more than 2. If it is 2, then apply unpaired test or ANOVA test. Later, you can apply for post hoc analysis. If your data is not equally distributed, so what you have to do, you have to jump to non-parametric test. Now the question comes why we are using ANOVA and post hoc analysis. Suppose you have 3 groups. Suppose you have group 1, group 2, and group 3. So for this part, I can't apply t-test. Okay, so for the t-test, we have 2 tests also, that is pair test and the unpaired test. So what is pair test? This will be in the same group. Suppose you went to a class, you take their baseline knowledge and they scored something. After the test, you gave some explanation, you teach those people, and after your class, you take the exam back. That will be your pair t-test. Suppose in this class, before the class starting, I took your test. You all failed, suppose. And after this class, I gave you again the same questions for the exam and you all pass. So we have a same group of individuals. It is not changing. So at that point of time, we have to apply pair t-test for our analysis part. Now suppose I am taking male and female, 2 different groups in this class. Suppose in the starting class, 10 male failed, 10 female failed. And after the test, all passed. So there we can apply unpaired t-test because here I am having 2 different groups, male and female. So if you have 2 different groups, always go with the unpaired t-test. If you have a same group, always go with the pair t-test. Suppose, let me give you one more example. I am doing a study for 6-month follow-up to check the health-related quality of life. On baseline, I took all the patients with heart failure and I took their scores. On 6 months, again, I took all the same patient and again I did the HRQL questionnaire. So in this situation, what test I will apply? Pair t-test or unpaired t-test? Any guesses? The question is, I am taking all heart failure patients with 6-month follow-up. I took their HRQL score on the baseline and on the 6th month. So what test we have to apply? Pair t-test or unpaired t-test? Perfectly fine. Pair t-test. Others? Others? Sanjot, Fatima, Sandeep, Ruth, Prachi? Yes, perfectly fine. We have to apply for pair t-test. Now suppose I have 2 different classes. I have class 11 and I have class 12. I gave some question to such people regarding the board questionnaire, and 11th class and 12th class scored something out of it. Suppose in 11th class, I created 2 groups, male and female, and same for the 12th class, male and female. I took their scores on 0, that means my baseline, and after 2 hours. So what test we have to apply now? Any guesses? Unpaired t-test, completely fine. Now one more example for you all. Suppose I am having 2 different classes, class 10th and class 9th. I took their score on the baseline and after 3 months. To find the statistical significance, what test we have to apply? Unpaired. Others? Others? Perfectly fine. All are going perfectly fine. It is unpaired t-test. Let me take one more example for you all. Suppose in this class only with the SPSS and CRMBS, we have 2 groups. CRMBS, and SPSS. I take their scores on 0 month and on 6 month. Now, what test we have to apply? Others? Can someone tell me why? Why we are going with the unpaired t-test? Why not paired t-test? Two groups, perfectly fine. Others? Any doubts for this part now? Any doubts? Okay, so we were on the ANOVA test. Suppose I am having three groups now. Initially, for the t-test, we were having only two groups or same group at two different point of time. Now, suppose we are having three groups, group 1, group 2, and group 3. I can't apply t-test over here because it will go against the rules of t-test. For t-test, we have to apply only for two groups. But here we are having three groups. So what test we can apply? We have to apply ANOVA test. If I am having variables more than three, then we have to directly go for the ANOVA test. Suppose ANOVA test came significant. So it will tell me that there is significant difference between all the groups. But suppose I want to find the difference in three groups. Okay, which group is much better? So for that, we have to go for the post hoc analysis. It will tell me, it will compare two groups now and will tell me which group is more good. Suppose we are taking three best friends. Friend number 1, 2, and 3. All scored around 80, 84, and 87 out of 100 in their group, in their class test. Now, if I apply only ANOVA test, I will get p-value less than 0.05. That is significant. That indicate that there is a significant difference in the groups. Now, if I want to find which group is much better, which friend score much better. So what I have to do, I have to apply post hoc analysis. So what it will do, it will compare 1 from 2 and 3. It will compare 2 from 1 and 3. So it will get me, now it will show me some different significant factor. Suppose it came significant. Suppose it came non-significant. So I will tell 1 is much better than compared to 2 and 3. So this is the use of post hoc analysis. You apply ANOVA test if you have more than three variables. To check among these three groups, which one is better, you have to apply for post hoc analysis. I hope this part is clear. Any doubts? Any doubts till now? If you have two groups, go with paired t-test or unpaired t-test. If you have more than two groups, go for the ANOVA. If you want to find which group is much better among three, apply post hoc analysis. See, ANOVA is nothing. This is only a t-test, but the developed t-test. In t-test, we are writing only for two variables. T-test is changed. It is modified to ANOVA test for three variables. So ANOVA is nothing, a t-test part only, but for the variables of more than three. That's it. Any doubts now? Anyone? Anyone? Prachi, Ravindra, Sandeep, Unisha, Rakesh, Sanjot, any doubts till now? Okay, then perfectly fine. So I hope you all are ready with your SPSS. We will go to our hands-on training now. So please do take your next few minutes, open your SPSS, and let me share my screen again once more with you all. So I hope you all can see my screen now. I don't have SPSS. Okay. Sir, can you please explain the adjusted odd ratio? Okay. Suppose you are doing one trial and you found multiple variables are showing significant odd ratio with your outcome. Suppose I am doing one trial. I found smoking, alcohol, fatty food is more related to the occurrence of heart failure or heart attack. But I have something. Suppose smoking is a more alcoholic thing, like smoking is a more strong factor for MI. So to prove that part, that smoking is more strong factor to cause MI, we have to apply adjusted odd ratio. Any doubts till now? So did you all open your SPSS? Can I have some response on the same? Can you access your SPSS now? Others, please open your SPSS so we can practice hands-on now. Others, you guys can go to Google, you can search SPSS, you can take it. It will be available for 1 month, free trial. Please take next few minutes, open your SPSS so we can have a proper hands-on training for SPSS. Okay, so how many of you have SPSS? Others, please be active so we can do a proper hands-on training. Okay, so Mahesh have, Shruti has, Sandeep have, Sanjot have, Suchi has. Okay, downloading. Okay, so please download it. Others, please do keep your SPSS open so we can proceed now. Okay, so such type of screen will appear on your screen. Okay, so how to transfer a file from your Excel, your desktop to the SPSS? This is the main thing what we all have to do. Okay, so what we will do, we will go to file. I hope you all are following me. Just try to follow my steps for the hands-on training. So what to do, go on file, click on open, click on data. Okay, such type of screen will appear on your screen. I hope you all are following me. Yes or no? Okay. Now suppose you can take one any Excel sheet of your choice from your desktop. Suppose I know my sheet, what I want to work on is on my download file. So I will click on download, but nothing is coming up. I can't see any Excel over here. Okay. I click on download because I know my file is over there in that folder, but I'm not able to see any Excel sheet over here. The reason is why, because my file type is SPSS statistics. This we have to change to the Excel part. So once you click on the Excel part, few things will come up on your screen. That is your proper Excel sheet. Now let me open my sheet with you. So such type of block will come on your screen. Do not unclick the first block. You have to click it. If it is not tick over there, just click it. I will tell you why. Because in Excel sheet, we have our first column. It will have some name of variables, gender, age, diagnosis, and all those things. That part we need as a variable in our SPSS. So if I click on it, it will change all those things to my variables. The next thing is sheet. So sometimes what we do is like we create multiple sheet in the Excel sheet. So suppose I want to work on statistical analysis on my sheet 2. it will show up automatically. But in my Excel sheet, I have only one sheet. So it is not showing more than two sheets, only one. So once all done, click on OK. Such type of screen will come on your screen. Are you all following me? Yes or no? Yes or no? Others, I hope you all can follow me properly. Others, any doubt till now for this part? Any doubt? Okay. So we go to file, open, data, select your file, change the file type to Excel. It will show multiple Excel sheet of your interest. You can click on open. Any doubts till now? Others? Ravindra, Mahesh, Fatima, Onisha, Sandeep, Mahesh, Shruti, Fatima, Rakesh. Any doubts? Okay. So on the top row, what we have are all variables. Duration, age, gender, BMI, SBP, hypertension, HbA1c. This is all my variable of interest. Below which I have all my variables of all of my patient data is here. Now there are few things that we all should know before going into the proper statistics. The first thing first is the variable view. Now suppose I want to change this coded. Here we can see gender is 0 and 1. Okay, here 0 is male, 1 is female. Okay, but I can't see male or female. So what we can do, we have to go to variable view, click on variable view, try to find the gender, click on gender, then click on values. So if I click on values, I will get such value label block on my screen. So I know 0 is what? Male, write male, click on add. 1 is what? Female, click on label, write female, click on add. I hope you all can follow me. Then click on OK. So if I go back to data view, now here again, it's showing like 01100. If I click on this option A1, this is value label shortcut. If I click on it, it will change to proper non-coding parameters like male, female, female, male, male. If I want, I can again click it back. It will change to code version. Any doubts till now? Any doubts? I hope you all are following properly. Okay. One more thing I will show you over here is the type. Now, if I click on it, I have multiple types over here. Numeric, comma, a dot, scientific notation, data, dollar, custom currency, string, and restricted numeric. So for the statistical part, for your level, for the normal advanced level, what we usually follow is the numeric and the string. Numeric will come only for the data which has numbers into it. And for the categorical variables like male, female, or any numbers or like any number thing, what you're writing, male, female, undergraduate, postgraduate, or UG, for that we have to follow string variable. But here we have all numbers, then we have to click on numeric part, click on OK. Now we have one more thing over here, that is measures. If I click on it, I get three options: scale, ordinal, and nominal. So what scale indicate that something is there in the continuous variable, that numbers are keep changing. Like suppose age, your age might be 20, 21, 22, 30, 40, 50, 55, 54, anything. That will come in the scale part. The next part, what we have is the ordinal and then nominal. The biggest difference between these two parts is the rank wise. If you can see the ordinal part, we can see some graph pattern is there, small, medium, and higher. This indicates the rank. Suppose I am writing economic status. It's like below poverty, under poverty, and above poverty. So we have rank here now, 1, 2, and 3. It will come in the ordinal part. The next part, what we have is the nominal. That means we have a group of population, but there is no rank-wise arrangement. Okay, suppose we have a class of 10 people. Out of 10, we have to arrange them in the rank-wise. Who scored top marks? Rank 1, then rank 2, rank 3, rank 4, and rank 10. This will show us the ordinal value. That means we have some rank over in our data. The next part, what we have is the nominal. There is no rank, but all are there at the same place. Scale indicate the continuous variable. Suppose your age, your marks, what you are getting. You are getting your marks in the exam, but we are not giving any rank to you. Your marks will come in some different number. Suppose out of 30 people, some scored 10, 5, 4, 50, 60, 64, 75, all those things. So here we have a continuous variable. That will be your scale variable. I hope this part is clear, Fatima. So till now, any doubt is there with respect to scale and other two parameters? Ordinal and nominal has only one differentiation, that is presence of ranking. If ranking is there or some category is there, like undergraduate, postgraduate, or higher degrees, it will come in the ordinal. If you have all the education in a same group, there is no rank, it will come in the nominal part. I hope this part is clear. Any doubts? Okay, so we will go to our data view again. So this is how your screen will come in your desktop. Now, suppose you might have noticed people are writing mean age of this and this we found in our study. In our study, we have 40% male, 60% female. So how to find this basic descriptive analysis? So what to do? You have to click on analysis, go to descriptive statistics, click on frequency. So once you click on frequency, you will get such type of block on your screen. Okay, suppose I want to find the mean plus minus ST of my age group. So what I will click on age, shift to variable, click on statistics. A new block will come on your screen, click on mean and ST value. So once you click on it, press continue and OK. New screen will come on your screen and this will show the mean plus minus ST of your data. That is how much? 58.5 plus minus 11.00. This is how you find the mean plus minus ST in SPSS. I hope this part is clear. Any doubts till now? Any doubts? No. Okay. No. Perfectly fine. Again, descriptive frequency. Now suppose again reset. Suppose I want to find the number of male and female in my study. Click on gender, shift to variable view. There is no need to apply for any test because this is your categorical variable, not a continuous variable. So there is no need to apply any test over here. Click on continue, directly click on OK. It will give me male and female frequency and percentage. So out of 471, I have around how many males? 366. And how many female I'm having? 105 out of 471. It will give me the percentage also over here. So this is how you calculate your basic descriptive analysis for your data. Any doubts? Any doubts? Anyone? Okay. So let me take one more thing for you all. That is go to transform. Now we are having here two things. Recode into same variable, recode into different variables. So I have one question for you. Suppose you are doing one questionnaire or online survey. You wrote age and you make subcategories. Suppose you are having two friends, one of you and one of your friend. In your questionnaire, I noticed you put age in the groups. Suppose 10 to 30, 31 to 40, 41 to 50, and one of your friend keep it blank. Let the patient write his own age. So which technique is much better? Any guesses? Which technique is much better? Let me open my OneNote for your practice. Suppose you are doing a questionnaire study. We have two people and one is taking age in categorical format. Suppose he is writing to tick option 0 to 10, 11 to 20, 21 to 30, and so on. Now, block are there. We have to click it in which range you are belonging. Second individual, what he or she is doing, he or she just wrote age. He will give questionnaire to you and you have to write your own age over there. Suppose I'm writing 45, 24. Third patient will come and write 12. Next patient came and write 25. So which technique is much better? So out of these two techniques, which technique is much better? Let me make it simple, A or B. Just write A or B with your preference or your reference. Which technique is much better? A. Okay, others? A. Others? Others? Why A? Why not B? Can someone tell me? Why you all are taking range part, not the writing part? Any guesses why? If you are writing A, I need your reason also. Ravindra, Shruti, Vishika. A is continuous. Okay. Code in SPSS. It's easy to tick. Okay. I noticed many individuals who are coming to me for the analysis part, they are using the coded range in the initial phase only. They are writing age in range and patient will come and tick in what age range he or she is belonging. So what you are doing for such part is, it is causing a huge number of data loss. Let me give an example to you. Suppose you are doing one study and you found out that individuals in the age range between 20 to 40 have significant amount of anxiety. This was your age group in your questionnaire. Suppose 0 to 10, suppose to 10, 11 to 20, 21 to 30, then 31 to 40. You noticed in your study after a test, individuals who are coming in the age range between 11 to 20 have significant amount of anxiety compared to the other groups. Now, suppose I'm asking you, suppose I ask Vishika, Ravindra, or Sandeep, tell me how many individual of age 24 is having anxiety. Suppose my age is 26. I want to find how many individual of age 26 is having anxiety. So Ken, now you can tell me whether this data is there or not in your SPSS. No, right? So this will cause a huge amount of data loss in your study. You will not be able to answer me my question answer because in initial phase only you took the data in the categorical format. So always try to collect data in the continuous format. If you went with the B option, if you let your patient write their own age, then with this help you can answer this question. Then I can tell, in my study, I have around 744 individuals out of 74, 744. 104 falls in the range of 24. And out of 104, 38 were having anxiety. Now I can tell many things if data is in the continuous variable. So if you are planning a study, always go with the continuous variable. Do not go with the categorical variables. I hope this part is clear. Any doubts? Anyone? So see, if you are having data in the continuous variable, while doing the analysis, we can transform the same into the categorical variable. There is no issue, but categorical cannot be changed to continuous, but continuous can be changed to categorical variables. So always try to get your data in the continuous variable. Now I will tell you how to change this data into the categorical variables. Again, we will go back to our SPSS. Suppose here we are having the age criteria. Here, what we have age in the continuous variable. Okay. So what we can do now is like, we can change the same into the categorical, but not in the other format. Now click on transform. Now we get two more options. Suppose recode into same variable, recode into different variables. Always go with the recode with different variables. Why? Because with this option, we will get the new column with our new data. If I'm going with the same variable, I'm doing a big mistake by putting the same number into the categories and it will cause my data loss. So always go with the recode with different variables. So how to do it? Click on different variables, select your age, put into the output variables block. Now we have to rename it. So write age underscore category. There is one more thing in SPSS. You cannot use special characteristics. You cannot use space bar. Suppose I'm using space. Let me give an example to you. I'm writing age space category. If I click on change, it will show me the error because SPSS cannot read space bar. It is the illegal character for SPSS. So what we can do, we have to put the underscore. So what we can do is like write age, put underscore, write category. Select it, copy it and paste to label and click on change. Now, next step will be old and new variables. Such things will appear on your screen. Underscore used. Okay, perfectly fine. So now I have a range. Suppose I want to put my variables into a range like what we were following initially, 10 to 20, 10 followed by all the ranges. Suppose I want age range of 30 to 40. The next step will be what? Click on one, click on add. Now any individual who falls in the age range of 30 to 40 will be count as one. The next step is what? 41 to 50. I will label it as 2. Now any individual in the age group of 41 to 50 will be counted as 2. Same we have to do for other people also. 51 to 60, make it 3, add. Then 61 to, I will directly make it 80 and click it 4. Click on add. Now we have data changed to the categorical variable. Initially, we were having age in the continuous variable. Now we are changing the same into the categorical variable. Now click on continue and OK. Minimize it. Go to the last part. Now see, here we have our data in the categorical format. This blank space indicates some amount of error is there. That means I did not put those age group in my range value. This might be less than, see, it is more than 86, but we put last was 80 only. That's why it's showing a blank space. So you have to check your age range and from that part, you can make the subcategories. I hope this part is clear. Any doubts? So the rule of research is like always take data in the continuous variable. Later we can change the same into the categorical format. There is no issue, but always take data in the continuous variable. Now, if you can recall whether my data is normally or not normally present. So what we can do now, suppose my age is there. So I can apply t-test with some other variables. Now I change my data of age into the categorical format. Now here I can't apply t-test. This is for the parametric. For such data, we have to apply non-parametric tests like chi-square. Suppose I am trying to find hypertension, yes or no. 0 is no, 1 is yes. So here we can apply chi-square, 2 by 2. These things we will learn in the upcoming classes, how to apply chi-square and all those things. Now, let me give you one more example, transform. Go to recode into different variables. Never click on same variable. It will cause data loss. Always click on different variables. Click on it. Now reset. Suppose I am taking age again here. Okay. Name, age, new. Select, copy and paste your label. Change to it, old and new variables. If I want, I can put range also the way we did last time. If I want, I can put two things also. I want all individuals who age is less than 60, and let me make it one, add. Now I want all individuals whose uh, age is more than 60. Now make it two, add, continue, okay. Now I will get two groups directly. Here, one and two, one and two. Till the end, we are getting the same range because we are creating a two groups specifically. So there is no limit. You can make multiple categories if you have data in the continuous variable. Now again, let's go to different variables, make it reset. Suppose I have data of BMI also here. Now I want to make a subcategory. Suppose I want BMI category. Remove space, put underscore, category, copy, paste, change this way. Now suppose I want a range. Suppose I'm taking this part, range lowest through and highest through. I want data of BMI of my individual patients. How many of my patient is underweight and overweight? Suppose I'm putting lowest through, 20 is underweight. I will put it as 1. So 1 is what? Underweight. Click on add. Now I want everyone who is more than 20 will be taken as overweight. Click on add. Continue. Okay. Now minimize it. Go to our last part. We will get our category over here. BMI 1 and 2. So this will give me my data into the categorical format. Any doubts till now? Any doubts? Ravindra, Fatima, Sandeep, others, Unisha, Sanjot, Vishika. Any doubts for this part? This is just the basics of SPSS, how to transfer your file, how to recode and how to make them into the categorical format. Because this will play a very important role if you are going for a statistical analysis. And if you want, you can put descriptive also for this new category, what we have created. Click on analysis, descriptive statistics, click on frequency. Now this is what we just now created. BMI and age category. We can remove it. We can just take two part. This two. Click over here and click on OK. There is no need to apply any test. There is no need for mean, median, mode. Can someone tell me why it is? Anyone? Any guesses? It is not continuous. Perfectly fine, Ravindra, because this data is in categorical format. So there is no need to apply any test over here. Continue and OK. I will get my frequency and percentage also. Now in your paper, how to write this part, I will tell you one simple thing. So what you can do, you got percentage. Suppose you got male and female. You got suppose 477 and 105. This is your frequency and this is your percentage. Suppose it is around 90% and 10%. So how to make a table for it? So write male and female, gender. This is your frequency, bracket, percentage. So for writing a table part, always write numbers. That's it. So male is what? 477. Bracket itself indicate percentage. So write 90. Bracket close. Same for the female. 105 and percentage 10. This is the way of writing in your table part. I hope this part is clear. Any doubts? Any doubts? Anyone? Others? String numeric once again. Okay. So this is what, let me go over here. This is the type of variable what you are entering. Suppose age is there. Okay. Age will be numbers only. It will not be in alphabets. So it will be numeric only. If it is in alphabet, it will change to the string variable. Suppose, let me give an example. Let me see once what is there. Okay. Here we have SCAG and PTCA. Here we can see some alphabets are there. like DVD, SVD, TVD, all things. In PTCA, what we have RRA, RFA. So these are alphabets. So if I go back to variable view, I can see string will be there. So where's my CAG and PTCA root? See, here it is. CAG is in string variable. PTCA the string variable. But all the numbers, see BMI, all numbers are there. SBP, all numbers are there. Hypertension, all numbers are there. It will come in the numeric way. So if you click on it, you can, if you want, you can change the same also, but it will not give you the proper test results. So number should be numeric, alphabet should be in a string part also. This is how what you have to follow for your analysis. This is the basics of SPSS. You have to do all these steps before going into the proper statistical analysis. Any doubts now? Anyone? Others? Okay, so this was your all about the basics of SPSS, how to enter the file, how to proceed with the statistical analysis. In the coming classes, you are going to learn about all the tests, parametric, non-parametric, t-test, unpaired t-test, chi-square, and all the other tests. So I think we can wind up if there's no more questions as such. Any doubts? Notes, you will get the recording for this class. Don't worry, Fatima. Others? Any doubts? This was just the basics of how to open, how to transfer your sheet into the SPSS. No doubts? So I think we can wind up now. There's no more doubts. Measure nominal, how we can get. This is what I'm not following you, Sandeep. Measure nominal, how we can get. I'm not following you, Sandeep. Maybe you are asking for this variable view, if I'm not wrong, this measure part. See, once you enter your data into SPSS, it will automatically think and change your data into the scale and other two parts. So there's no need to change as such, unless you are doing any other coding part. See, for the last three categories, we did some coding. We don't have any categorical, we don't have any rank over here. So as per the SPSS, there is no rank. Automatically, it changed data to the nominal part. So if you can see, age initially is in scale part. Further, we have changed into the categorical format. That is age, new age category. Automatically, it changed to the nominal part. So there is no need to take tension for this part. It will automatically change. I hope this part is clear now, Sandeep. Others, any doubt till now? Okay, so I think we can wind up if there's no more questions then. Can we change the string type to numeric data type? Of course we can change. So what to do? Just go on this part, click on numeric, click on this part, click on string, okay. Simple it is. You can change it, but better keep in numerical part. If you are seeing any number in your variables, keep the same in the numerical part. No need to change to string part. You can change, but there is no need to change. It will hamper your statistical analysis. If you are noticing any alphabets, change the same to the numeric part. If you have string part, change it. Suppose I am putting this part numeric to string. Okay, I change this part to string now, and this is not scale part. So I can't apply few tests over here. I can't apply t-test over here. So what I have to do, this categorical, this variable is applicable to go for the parametric test. But because of my error, I change numerical part to the string part. So what will happen? It will show me the wrong test. This test can be go for the parametric, but now I have to go for the non-parametric. So better do not change it. In the end, it will only hamper your result. That's it. So if you are seeing numbers, put as numeric. Alphabet, put as string. That's it. No need to change. Any doubts? Okay, so first thing first, do you have any doubts for this sheet now, SPSS? Any doubts? Others? Okay. Any doubts? I think I was mute in the last part. Am I?
Yes, sir. Sir,
Uh,
in my SPSS, I will see the one tab also overview of that as
okay. Sorry for the interruption because I think my mic was mute and I was doing something on SPSS. So what I was telling it is go to transform, click on different variables. Okay, let me make it reset for you all. Click on CAG. As Tamil was telling, he wants the number part DVD, DVD, TVD, SVD. So what we can do, click on name because we have to change name. If I write CAG, it should not be matching with the data what we already have. So we have to change it. Suppose it is 02. Click copy paste into the label, change it. Now old and new variables. Now what we have to do, this value should be matching with the value what we have in the main working sheet. Suppose we are having here capital DVD, capital SVD, capital TVD. If I write small DVD, then SPSS will never catch this capital TVD. It will show me the blank column. So what we have to do, we have to write capital only. It should be matching with the main working sheet. SVD capital, make it one, click on add. Same for DVD, all capital, matching with main working sheet. Make it 2, add. Same for DVD, all capital, make it 3, add, continue, OK. Now I will get one more column in the end in numerical format. I hope this part is clear, Ravindra, for you. And for Fatima, she was asking why drugs are in numerical value. This is because it is coded. See, 1, 2, 1, 2, 1, 2. So in the initial Excel sheet, you should never code anything for the statistician. Always give in the proper format, always give in the continuous variable. Later we can change from our own side, but always try to give uncoded thing and things should be in continuous variable. I hope this, Fatima, I hope your part is clear now. Others, any doubt? Any doubt? So I think we can wind up now if there's no more questions as such. Should we? Okay. So I think we can wind up now. So thank you so much everyone for your attention.